Welcome to the lecture series of numerical methods. We are discussing about initial value problems for ordinary differential equations. Under this topic, in the previous lecture video, we have discussed Taylor series method, and today we are going to discuss about Euler's method. Some of you may say that it is Euler's method. Doesn't matter, you can pronounce Euler's or Euler's, doesn't matter. So look at the method. Consider the first order differential equation dy by dx equal to f of x comma y. Let us solve this differential equation under the condition y of x naught equal to y naught. The solution of equation 1 gives y as a function of x, which may be written as y equal to f of x. So under these methods, we are going to solve the first order differential equation under various kind of methods. Here we are going to discuss about Euler's method. So here also we are going to solve the same differential equation first order with the initial condition y of x naught equal to y naught. The result will be a function of x that will be denoted as y equal to capital F of x, that is a function of x. So what is the procedure under Euler's method? The procedure is, consider dy by dx equal to f of xy with y of x naught equal to y naught. Integrating equation 1 between limits x naught and x1. Therefore, y1 equal to y naught plus integral x naught to x1 f of xy dx. We can call this as equation 2. Assuming that the function f of x comma y equal to f of x naught comma y naught in the interval x naught to x1, therefore we can get y1 equal to y naught plus x1 minus x naught into f of x naught y naught. x1 minus x naught is nothing but interval of x data, that is h. So y1 equal to y naught plus h into f of x naught y naught. We can call this as equation 3. Instead of this x naught x1, if we are taking the next interval x1 to x2, we can get y2 equal to y1 plus h into f of x1 y1. So in the next interval we can take x2 x3, that we can get y3. Okay. So proceeding like this, yn plus 1 equal to yn plus h into f of xn yn. So this is the general result of Euler's formula. Y suffix n plus 1 equal to y suffix n plus h into function of xn yn. So this is the generalized formula of Euler's method. So how to do problems under Euler's method? So this is the procedure. First we have to take the given differential equation with the interval. For suppose the first interval is x naught to x1. So we are going to write the result as y1 equal to y naught plus h into f of x naught y naught. Similarly, next interval y1 plus h into f of x1 y1. So in the nth case, this can be written as yn plus 1 equal to yn plus h into f of xn y1. So how to do the problem under this Euler's method? First we will write the initial condition, what is given in the question, y of x naught equal to y naught. With this initial condition, we can write our x naught and the interval h value. After that given differential equation, then we have write the formula of Euler's result. In this one, we are going to substitute the value of n equal to 0, that is our first iteration, n equal to 2, that is the second iteration. Like that we will do the problem under Euler's method. So now we can see a first problem. The first problem is solve dy by dx equal to equal to 1 minus y such that y of 0 equal to 0 using Euler's method. Find y at x equal to 0.1 and x equal to 0.2. So in this question, differential equation is given and the initial condition is also given. So we are going to find the value of y at x equal to 0.1 and x equal to 0.2. So in the two places we are going to find the y value. So as I told you already that how to do the problem, first we will write the given initial condition. Using this initial condition, we are getting our x naught and y naught, then the given differential equation. After that we will write the generalized form of Euler's result. Substituting the value of n equal to 0, 1, 2, we can get the answer for the given question. Okay. So look at the solution. Given y of 0 equal to 0. We know that Okay, if you want you can write, doesn't matter, you need not to write and all, just to understand yourself only I am writing this. Y of x naught equal to y naught. Okay, this is the basic. So you can compare the given initial condition with this one. In the place of x naught, here we are having 0. In the place of y naught, we are having 0. Therefore, what is our x naught? X naught equal to 0 and y naught equal to 0. From the given initial condition only we are writing this. So look at the question. In this question it is given that find y at x equal to 0.1 and x equal to 0.2. And here we have written x naught equal to 0. What is h? H is nothing but difference between the x data. So here h is equal to what? H is equal to 0.1. So h is equal to 0.1 because here it is x naught is 0, x1 is 0.1, x2 is 0.2. So obviously our h is 0.1. So also given that f of x comma y. F of x comma y is nothing but given differential equation. What is the given differential equation? Dy by dx equal to 1 minus y. That is the given differential equation. Now the Euler's result is, what is the Euler's result? Yn plus 1 equal to yn plus h into f of xn comma yn. So we can call this as equation 1. Now we are going to give value for n equal to 0. Why we are giving values? Because in the question it's given that x equal to 0.1 and x equal to 0.2, we are going to find the value of y. Okay, and in the initial condition it's given that y of x naught equal to y naught. So obviously the first value of x is what? Y of x1 equal to y1. Okay, so y of x1 equal to y1. This one we can keep in our mind. Y of x2 equal to y2. These are the two values can be written as like this. Y of x1, that is y of 0.1 equal to y1, y of 0.2 equal to y2. These two values only we are going to find. So in this one, to find the first value y1, we can give n equal to 0. Is it clear? Why we are substituting n equal 0? We are going to find the value of y1. How to get y1 here? Put n equal to 0, we can get y1. That is the reason why we are substituting n equal to 0. So put n equal to 0 in equation 1. What will happen? Substitute here n equal 0. So y1 equal to, what will happen? Y naught plus h into f of x naught comma y naught. Is it clear? Okay. So here given f of xy, what is our given f of xy? Given f of x comma y is 1 minus 1. In this one we have to put x as x naught and y as y naught. Okay. So what will happen? F of x naught comma y naught, which is equal to, wherever x is there you have to make it as x naught, y is there you have to make it as y naught. Here only y, so 1 minus y naught. What is our given y naught? Given y naught is 0. Okay, so which is equal to what? 1 minus 0. Therefore f of x naught y naught value is what? 1. Okay, so f of x naught y naught value is 1. So we know the value for y naught, f of x naught y naught and h value. Therefore back to this one, y1 equal to, therefore y1 equal to y naught. What is our y naught? Y naught is 0 plus h value is 0.1. Okay, 0.1, f of x naught y naught, that is 1. So what will happen? y1 equal to 0.1. Okay, what is y1? y1 means that y of x1. That means what? We have to find out y value at the point of x equals 0.1. So it's understood that y of 0, therefore y of 0.1 equal to 0.1. You please don't confuse your 0.1 with this 0.1. This is nothing but our x1 value, this is your y1 value. In this question, okay, unexpectedly both values are equal, but it's not in all the problems. Okay, so this is the first value of y at x is equal to 0.1. What is our next value? X is equal to 0.2. For that what we are going to do? We are going to substitute n is equal to 1. So that only we can find the value of y2. Is it clear? So what is our next step? Next step, put n is equal to 1 in the equation 1. Okay. Put n is equal to 1 in equation 1. Okay. So what will happen? y2 equal to, y2 is equal to y1 plus h into f of x1 comma y1. Is it clear? F of x comma y is 1 minus y. We want the value of f of x1 y1, that means 1 minus y1, 1 minus y1 value just now we got it. What is that? 0.1. So 1 minus 0.1, it's nothing but 0.9. Therefore, our f of x1 y1 is 0.9. Is it clear? Okay. So in this one, that is in our y2, we know the value of y of y1, h value f of x1 y1. Therefore, our required answer y2 equal to y1 means 0.1, just now we got this answer, okay, plus h value, h is also 0.1, isn't it, into f of x1 y1, that is 0.9, okay. So obviously our y2 value is 0.19. Therefore, how we are supposed to write our solution? Y of 0.2 equal to 0.19. It's understood that y of 0.2 is nothing but what? Y of 0.2 is nothing but y of x2 equal to y2. Okay. So instead of writing y of 0.19, you can write a, or this is nothing but y2 equal to 0.19. It's understood that y2 means y at the point x2, the answer is 0.19. Is it clear? So this is the way we have to do the problem under Euler's method. Is it clear? So what is Euler's method? Under the Euler's method, first we have to take the initial condition. With the initial condition and the differential equation, we have to write the Euler's result, yn plus 1 equal to yn plus h into f of xn yn. So in this one, we have to put the value of n equal to 0 and n equal to 1. When n equal to 0, we can get the first value of x, and n equal to 1, we can get the second value of y. See, in this question, it's given that find y at 2 point. If it is only 1 point, means it is enough to put n equal to 0. Okay. Thank you for watching.